My name is Juras, and I'm currently studying design and manufacture under the guidance of Dr. Rashidi. Today, I'll be sharing my personal and professional journey toward becoming an expert in additive manufacturing, a field that is not only at the forefront of technological innovation, but also deeply aligned with my passion for design, engineering, and sustainability. I'll walk you through what inspired me, what I've learned, the direction the industry is headed, and how I plan to make a meaningful impact. For me, it was the thrill of creating things, taking a concept and turning it into a functional object. As a child, I was always building, sketching, or experimenting with how things work. Over time, that curiosity turned into a love for 3D design, engineering, and technology. I realized that I enjoy solving problems visually and technically, figuring out the most elegant way to bring an idea to life. I also loved the creative side of engineering, using form and function together. This blend of creativity and problem solving naturally led me to additive manufacturing, a field where digital design and physical creation come together seamlessly. Design and manufacturing, I found additive manufacturing to be the most exciting and future-focused. AM, or 3D printing, is transforming how we think about making things, from the materials we use to how products are distributed and customized. I chose this field because it allows for complex designs that traditional methods can't create. It supports on-demand, localized production, reducing waste and transportation, and it's already being adopted in critical industries like aerospace, healthcare, automotive, and consumer products. My vision is to use AM to build sustainable, scalable, and accessible manufacturing systems that can solve real-world problems, especially in underserved areas. Manufacturing, exactly. It's a process that builds objects layer by layer, directly from a digital 3D model. Unlike traditional manufacturing, which often subtracts material through cutting or machining, AM is additive, only using the material needed. There are several technologies in AM. 1. FDM, common and affordable, using melted plastic filament. 2. SLA, uses ultraviolet light to cure liquid resin into solid parts. 3. SLS, uses layers to fuse powder materials. 4. DMLS, prints metal parts with high strength and precision. These technologies are already being used to create custom prosthetics, aircraft components, car prototypes, and even consumer electronics. What's exciting is how accessible these tools are becoming. Even desktop 3D printers now offer powerful capabilities. Some of the most exciting current trends include 1. Multi-material 3D printing, which allows for parts with varied textures, colors, and functionalities all in one process. 2. AI-driven generative design, where software optimizes shapes and structures for weight, strength, and efficiency. 3. A shift towards sustainable printing materials, including biodegradable polymers and recycled composites. 4. Decentralized manufacturing, where parts are produced locally, reducing the need for global shipping and warehousing. One standout innovation is bioprinting, where layers of living cells are printed to create tissues, potentially even organs. And a powerful case study is GE Aviation, which redesigned a fuel nozzle using AM, reducing 20 parts into a single, lighter, stronger one, changing the way jet engines are made. Additive manufacturing is incredibly promising. Industry reports predict the global AM market will exceed 60 billion by 2030. That growth is being driven by a shift from prototyping to end-use production, the integration of AM into smart, automated factories, increased demand for customization, especially in healthcare and consumer goods. Career-wise, new roles are emerging, such as additive manufacturing engineers, design for AM specialists, AM material scientists. There are also huge opportunities in startups, innovation hubs, and humanitarian applications, like 3D printed homes or medical devices in remote regions. I see this as a field where I can grow professionally while also contributing socially and environmentally. Technical skills and soft skills is essential. On the technical side, I'm learning tools like SolidWorks and Fusion 360 for 3D modeling, Cura and Preform for slicing and print preparation, material science for understanding polymers, metals, and composites, and crucially, how to apply design for additive manufacturing, or DFAM for short, principles, thinking differently to make the most of the technology. But just as important are soft skills such as creative thinking to explore new design possibilities, problem solving for real-world constraints, communication and collaboration, especially for working in cross-functional teams. I'm using platforms like Coursera, LinkedIn Learning, and online maker forums to build and refine these skills. I'm an expert in this field. I've mapped out a roadmap with short, medium, and long-term goals. In the short term, I'm focusing on self-education, completing courses, certifications, and experimenting with my own 3D printer to understand the nuances of different materials and techniques. In the medium term, I aim to intern with companies that are using AM for real-world applications. I'll also build a portfolio of projects, from prototypes to case studies, that showcase my ability and creativity. In the long term, I plan to attend industry conferences like FormNext and Rapid plus TCT, contribute to open source AM communities, and pursue advanced studies in manufacturing or materials science. Step by step, I'm building the foundation to not only work in this field, but to lead in it. Motivated by impact. I believe additive manufacturing has the potential to solve urgent challenges, from sustainability to access. My mission is to promote zero-waste manufacturing by designing smarter, using only what's needed, develop and test bio-based materials that reduce environmental impact, create low-cost medical devices or tools for underserved communities where traditional supply chains fail. Long-term, I want to become a leader in AM innovation, perhaps launching a social enterprise or working with global organizations that use technology for good. I also hope to mentor others, helping future students and professionals enter this exciting field. It is more than a technical process. It's a transformative force. It aligns with my passion for design, technology, and sustainability. It's a field that's growing fast, changing lives, and opening up new ways of thinking about production. I'm committed to mastering this technology, applying it to solve real-world problems, and sharing what I learn along the way. Thank you so much for listening. I'd love to take any questions in the comment section below, or hear your thoughts on where you see this technology going. Please don't forget to like and subscribe, and thank you for listening.